the last thing to look at in this chapter, now that we've kind of talked about how to solve quadratic equations and we've looked at some different strategies here, is some of the applications of quadratic equations. So anytime you see applications, that means we're going to look at some word problems. So the first one we're going to look at is the product of two consecutive integers is 14 more than 6 times the smaller integer. So we want to find what the two integers are. We've done problems like this before, but when we looked at them before, they were the sum or the difference of the integers, but now we're multiplying them together. So we need to define our variables and kind of decide how we want to define these consecutive numbers. So let's let n equal the smaller integer. Okay. So if my integer is, say, 6, then the next consecutive integer would be 7. It'd be the next one. If it was -2, the next consecutive integer would be -1. It would be the next one. So the way I'm getting from n to the next integer is to just move 1 over. So that means that n plus 1 is the next consecutive integer. All right. So the product of those integers, that means that we want to multiply them. So product, we're going to do n times n plus 1. And then it says the product of two consecutive integers is. Remember, is always tells us where our equal sign is going to go. So it's going to be 14 more than, that means we're going to add 14 to whatever it tells us next, 6 times the smaller integer. Well, the smaller integer is n, so that would be 6n. So here's the equation now that we need to solve. The first thing that we need to do is go ahead and distribute over here. So n times n gives us n squared, and n times 1 gives us n. And so now I see that I have that n squared, so I have a quadratic. That means that we need to try to use factoring to solve this. And remember, one of the things we talked about is that if you're going to use factoring, you have to get the equation equal to 0 in order to use that zero product property. So I'm going to subtract 6n. These are like terms here. Here's where my equal sign is. And then I'm going to subtract 14. Well, there's not really anything that lines up with 14, so I'll put it down there. So that gives me n squared minus 5n, and then that minus 14 just has to go at the end. But all of this went away, so that means that on the other side of my equal sign is just 0. And from there, that is factorable. We get n minus 7 times n plus 2 equals 0. And so I get 2 possible answers. I get n could be 7, or I get that n could be -2. Now, we just need to see if both of those are going to make this statement true. And they should, but we just want to kind of check it out to see if they both work, because it's possible that they may not given this situation. So if we plug them in, let's see, if we did n equals 7, then that would mean that our numbers are going to be 7 and 8. That gives us 56. So we want to know, is that 14 plus 6 times the smaller integer, which was 7? And that's 14 plus 42, so that one works. So 7 and 8 could be the integers. Let's try -2. If I have -2, the next one would be -1. And so that gives me +2. Is that 14 more than 6 times the smaller integer? Remember, -2 is smaller than -1. And that also comes out to 2. So that one also works. So we have 2 possible answers. They could be 7 and 8. Or they could be -2 and -1. Now, just make sure that you read the problem really carefully, because sometimes it'll say things like 2 consecutive positive integers. And if that was the case, then 7 and 8 would be the only correct answer. So you just got to make sure you read carefully. So there's one example. Another example, a common application of quadratics is with area. So I'm not going to solve the rest of these from here on out, but I'm just going to show you how you would get them set up. So it says a rectangular sign has an area of 40 feet squared. So I have a rectangle, and I know that its area is 40. It tells me that the width is 3 feet shorter than the length, okay? So whatever, that tells me that whatever the length is, we can call it x. If the length is x, the width has to be 3 feet shorter than that. So it's got to be x minus 3. If it said like 2 more than twice the width or whatever, you'd write the equation in that kind of way. Now, the reason I knew to make x be the length is because they described how to find the width. They did not describe how to find the length. So length has to be the unknown. We can use that unknown then and the description to figure out the width, which was x minus 3. So area is length times width. That means this would be x times x minus 3. And the area is equal to 40, so we would get this here. Same thing as the previous problem. Distribute here, and that equals 40. Now we got to subtract 40 from both sides, so that makes it negative when it comes to the other side. And now from here, you would factor and solve that. Now, think about the kinds of answers you could get here. If you get a negative answer, that option does not make sense in this scenario. Let's actually go ahead and solve this one so that you can see what I mean. This would factor to, let's see, 8 and 5. So x minus 8 and x plus 5 equals 0. So that tells us that either x equals 8 or x equals negative 5. Well, the length of our sign can't be negative, so that one doesn't make sense. So that tells us that we have a length of 8 feet, and 8 minus 3 means we have a width of 5 feet. So depending on the situation, negatives don't make sense. Like you can't have negative time, you can't have negative distance, things like that. So just something to keep in mind. Okay, here's another really common application with quadratic functions. This would definitely be something I would expect to see on the next test. So it says a stone is dropped off a 64-foot cliff and falls into the ocean below. The height of the stone above sea level is given by the equation h is equal to negative 16t squared plus 64, where h is the height of the stone in feet and t is the time in seconds. Find the time it takes for the stone to hit the water. So they went ahead and gave us the equation here. So we want to know what is t at the height where the stone hits the water. Well, if h represents the height of the stone, like above the water, when it hits the water, what would the height be at that point? And hopefully you guys can see that the height would be 0 feet at that moment. It's fallen all the way off the 64-foot cliff and hit the water, which would be ground zero. So that means that the equation we want to solve here is 0 equals negative 16t squared plus 64. Now this one's already equal to 0, so you would want to look at solving by factoring here. And if you look first for a GCF, you see that you can factor out negative 16. So that gives me t squared minus 4. That's a difference of squares. So we get t minus 2 and t plus 2. And so where do each of these equal 0? Well, negative 16, that never equals 0. T minus 2, that would equal 0 at positive 2, and t plus 2 would equal 0 at negative 2. Again, no negative time, so the answer would be 2 seconds. Okay, that's a really common application, and they usually will give you the equation in those types of problems, at least for now. And so that's something that you want to look at. The last thing that I want to show you is the Pythagorean Theorem. Somebody brought this up in class the other day. So you may recognize this from geometry. This tends to be like the thing that everybody remembers. So the Pythagorean Theorem is for right triangles, and it gives us a relationship between the two legs of the triangle. The legs are going to be the sides that form the right angle. So a right angle makes 90 degrees. That's what this box represents here. It tells us that's a right angle. So this side is a leg and this side is a leg. And then C is always the hypotenuse, which is always across from the right angle. And it's also always the longest side in the right triangle. So you have leg, leg, hypotenuse. So this is the sum of the squares of the legs equals the square of the length of the hypotenuse. So let's look at just kind of a real simple example here that we could figure out. Okay, so if I want to find the length of the missing side, I see that the hypotenuse here is 12. So I know that this side is C. It really doesn't matter which one is A or B after that. So you can label them however you want. A and B can switch and it won't make a difference. So if I set this up, I'm going to have A squared, which would be 8 squared, plus B squared, which would be Y squared, equals C squared, which is going to be 12 squared. So we get 64 plus y squared equals 144. Now, you may know a different way to solve this than by factoring, and that's okay if you want to do it that way. But since factoring is what we've been working on, I don't want to try to teach you something new. So if I want to factor this, what I would do is I would probably rearrange this first so that it's in standard form. And then I'm going to subtract 144 from both sides in order to get it equal to 0. So like this. And we get y squared minus, what is that going to be? 80? Yeah. 80 equals 0. And unfortunately, that is one that does not come out to be factorable. So you would have to use square roots to solve this, but I'm not going to give you one that does that. But from here, you would factor, if you could. This one's not, unfortunately. This was not a great example. And you would get your solutions for y. Obviously, again, a negative answer doesn't make sense here because it's a distance. Let's look at one that's just slightly more complicated here. So, this kind of goes with slope. This is going to be a lot of things that you would see in construction or architecture or different things like that. So a 13-foot board is used as a ramp to unload furniture off a loading platform. If the distance between the top of the board and the ground is 7 feet less than the distance between the bottom of the board and the base of the platform, find both distances. So that's kind of a lot of stuff to think about. But the way I process this is that I have some sort of ramp like this, okay? And so I have the distance between the top of the board and the ground, and then I have the ground. So this is where my right angle would be. We know that the board is 13 feet, so that's got to be the hypotenuse there. So it says the distance between the top of the board and the ground, so that's this one, is 7 less than the distance between the bottom of the board and the base of the platform. Well, the platform is right here. It's like this. Like this is what the ramp is going up onto. So the base of the platform is here. So the second thing that they're talking about is this right here. Now, just like I told you on that first problem, which one did they describe to us? They described the distance between the top and the ground. That means our variable needs to be this side, because that was the one they did not describe. Now I know that the yellow side has to be 7 less than that. So that's going to be x minus 7 in there. I don't know if you can see that. X minus 7. Okay, so when we set this up using the Pythagorean Theorem, I just want to show you one thing to keep an eye out for. So we have x squared plus, you have to square the entire side, x minus 7 squared, and then that's going to equal 13 squared. Don't forget that when we looked at these before, I showed you how to multiply these out. It is not just x squared plus 49. That means x minus 7 times x minus 7. So you're going to have to distribute that out. Or, remember the little chant that I taught you was square the first, square the last, multiply and double. So we would get negative 14x. That is the same thing that you would get if you came over here and distributed this all out. So either way is fine. So now we can combine our like terms. That gives me 2x squared minus 14x plus 49 equals 169, and then get it equal to 0. So subtract here. 2x squared minus 14x minus 120 equals 0. And from here you would factor it and solve it just the way that we've done all the other factoring problems. But it's getting it set up that's a little bit tricky. So those are just a couple of applications of quadratics that will be good for you to have in your back pocket.